This is the change of base formula. There was a time, and there still is a time, whenever the calculators only had on it two things. One is natural log, which is base E, and common log was what we call it, which is base 10. And there was a time also where you could get a calculator was designed specifically for business. And the only log that was on that calculator was base E. So here you are sitting there, you don't even have base 10 on your calculator, you just have base E. What do you do when you had to calculate something that was to another base? Well, you could use the change of base formula. And the change of base formula basically says that you can either use natural log, which is what my business people used to have to do, because that's all they had on their calculator. And it says that log, whatever that base is of some quantity, is equal to the log of the quantity divided by the log of the base. That would be base E. If you were using base 10, then that ratio, or the division, is using base 10. And you can do anything between any arbitrary logs that way. I look at it this way: if I have log to some base of some argument, that it translates into whatever logarithm you want to do, the log of the argument divided by the log of the base. So log of the argument divided by the log of the base. And that I have on my calculator. I could do natural log of the argument divided by natural log of the base. The logs have to be the same. So if I wanted log base 13 of 2, this would be the log of the argument, which is 2, divided by the log of the base, which is 13. And so in my handy-dandy little calculator, I would do the log of the argument, which is 2. Make sure I put the parenthesis after 2, because that tells me I'm ending that argument, divided by the log of the base. So this would be the log of 13. And this comes up with, and then what did they say? Answer is exact form. This is exact. Approximate using, 9 decimal places. Give me a break. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's that last 4. So essentially my calculator is giving it to me to 10 places. So it's then we can say it's approximately 0.270238154. It's like, how many decimal places do you need? Give me a break. Or you can have it as, in this case, this would be the log of the argument, which is 5.417, divided by the log of the base, which is 3. That's your exact answer. And approximate. Now, what your calculator has is something called deep recall. I know Freddie showed you that. But if I do second enter, and then hit the enter button, that brings back the last thing I did. And I can edit that thing. That comes in very handy when you've got a repetitive set of calculations going. So now I've got the log of, and I'm just going to hit insert, second insert, and 5.417, and I'll delete that 2, divided by the log of 3, and I'll just delete the 1. Enter. That's deep recall. And let me show you some more about that, but let's finish off this problem. This is 1.5 3, 7, 8, 8, 7, 5, 5, because I got a 6 on the end. Now, deep recall goes as far as it has what's called in the computer world a buffer. So it's a temporary storage area and only holds so much information. So I can do second enter, second enter, second enter, second enter. It'll bring back calculations that I've done all along. Some of these are from you and some of these are from intermediate algebra. And eventually what will happen is I can go through and I will come back to the last calculation I did. So there's a whole series of things that are there. Some of the newer calculators, and I'm not sure whether this one does it or not. Yeah, notice I'm now jumping up. This guy here, and you can try it with your up arrow and down arrow, I'm jumping through that buffer. So I can go up and down that buffer, and then once I hit something that I want, I'd like that guy, I press enter. Whoops, sorry. You went a little overboard there. Let me delete that. It picked out the guy I wanted, then brought it down, and I can do my calculation again. So some of your calculators have it, some of yours don't. When they come up with something newer, sometimes it's got some things that are built into it. What this one also has built into it, and like I said, the other option is second enter. All of them have that you can second enter till you get to the thing that you want. And by the way, when I'm scrolling up, it does have a name. That name of the thing I'm going up is called a stack. It's kind of interesting. All computer terms now. Well, if I go under math, some of you have this, some of you don't. This is all algebra stuff. We can do that. This is calculus. This is nverb. This will be doing, this is log base. Now I am right now in, I think I'm in classic mode. So that'll come out with that command. The question ends up being, somebody's the argument, somebody's the base. I don't know which way. I've got to put it in a certain way. So let's see. Do I put the argument in first, then the base? I should come up with 0.27 if that's the correct thing. Argument in this case is 2, comma is above the 7, and the base is 13. And let's see if indeed I come up with 0.27. Yes. So argument first, base second, with that particular command. All of you have, I think, almost all of you have that command. I don't know if the 83s have it. You know, 83s do not, but I know the 84s do. And so you put the argument in first, put the base in, and then it'll actually do a change base formula for you. If I change my mode from classic to math print, come back out to the home screen, and now I do math and come down to log base. Now it comes up exactly how it's supposed to look, and the base was 13 and the argument was 2. Math print drives me crazy. I'm a creature of habit, so I'm used to not using math print. So you can do all kinds of things depending upon which calculator you have. A lot of them are different, but you can work with it. Change a base formula. Now these are graphs, and I wouldn't want to meet this guy in a dark alley if I have to graph it, because he's base 4. He's going to look like any other logarithm, by the way. Just with a different base. But if I wanted to graph him on my calculator, I would put the log of the argument divided by the log of the base. And that would give me a graph. He has a VA at x equals 3, because that's what makes x minus 3 0. So he's going to look like any other logarithm. So let me change back into classic mode since. And y equal the log of the argument divided by the log of the base. Now, on your calculators, the basic graphing window, let me get some space here. So this would be the standard graphing window. In other words, your basic piece of graph paper. On x is 10, minus 10. On y, minus 10, 10. That's your basic graphing window on the TI. I never know where my calculator has been and what I've done with it last, or if somebody borrowed it from me and did something with it. So what I normally do is under this button called Zoom, if you hit Zoom, it's got all kinds of zooms. Zoom box, zoom in, zoom out, zoom decimal, zoom square, and notice zoom standard. I usually go down to zoom standard, zoom 6. What that does is it puts my piece of graph paper in the middle of the window so that I'm going from minus 10, 10, minus 10, 10. And if I need to adjust my piece of graph paper after I've set it, I can do that. It's an automatic zoom, which means once I press enter, it'll bring up the piece of graph paper of that size and then do the graph. So it's completely automatic. So now I press enter, and there it comes. He looks just like what we think he would look like. And if you notice, at 3, he starts downward. And then you may say to yourself, it looks like he stops. Well, here's what the problem is when you're graphing. The little boxes that light up to get black are called pixels. And essentially what happens is each pixel has a numerical value. When it gets at partial pixels, it doesn't do partial pixels. It's either all or nothing. So it says it's going to stop there. Why? Because if it goes to the next one, it's on the other side of 3. So it won't continue. So if I hit trace, and trace is like the bug on the graph, and notice what it did. It put the graph, that's what I'm graphing right there, and it tells me what the x value is. And notice, what does it say? I have no y value. Why? Because there's a graph at x equals 0. No. So if I hit the left arrow, it starts moving over, and now I'm on the graph proper. And it's giving me certain x and y values. If you notice how the x value is, when I go to the left, it's in increments of about, what, a tenth or 100th, something like that. That's why when there's something in between, it reaches a point where it just can't do it anymore. So it's never going to hit 3, because you can see as I'm going to the left, that's as close to, I may get a little bit closer to 3. Nope. So notice it just went over 3. So essentially, that's about as good as I'm going to get, because the next thing it's got to turn off, in other words, to get black, is a number which is basically not part of the graph. So that's why your graphs stop. That's another reason why you need to know something algebraically of what this thing's supposed to look at, because it doesn't stop. It keeps on going forever and ever, forever, downward to negative infinity. So you can get a graph up, but it's not going to necessarily be totally accurate. But if you know something about that graph, you would know that it continues on down, and you can continue down with your arrow with your VA in place. See, technology can only do so much. It can't do it necessarily for it. You've got to be some engagement here, and you have to know a little bit about what's going on. That's part of the reason why you have to do some of this stuff, and the graphing by hand and some of the rest of it. Why? Because you're not going to necessarily get accuracy. With your calculator, I can even go on to something which is a little better. I'm still not going to get necessarily an accurate graph. Why? Because it's got the same pixel problem as any other piece of equipment would have, or program would have. We're doing a program. Now, by the way, this doesn't change out of Zoom Standard until I change it out of Zoom Standard. So if I put another graph in there, it's still going to be Zoom Standard. If I want to graph this would not be much fun at all. And you're going to say, why? This guy is changing. The base changes, the argument changes. You put an x in, every time you're going to get a different base, every time you're going to get a different argument. So then this then becomes the log of the argument divided by the log of the base. So under the y equal menu, the argument is x minus 2, so I can use that guy. And now the base is x plus 2. And now I'm just going to hit graph because he's in standard mode anyway. I don't have to do anything, I know, because I've not done anything in between. So there he is. Gracious, he looks like a logarithm. And notice you have a VA at what you would expect it to be at 2. A VA at 2, and that's going to continue down at 2. That's why the first thing when I'm doing a hand graph, I always put in all my VAs and HAs. Because then I know essentially where things are going to collide. Learn more about your calculator today than you ever wanted to know, I'm sure. Now, if I wanted to change the graphing window and say, you know what, I know that I don't need that left-hand side. I don't need anything anything to the left of 0. I can go in under Window, and notice there's my minus 10, 10, minus 10, 10. X scale, that means that each tick mark on that graph paper is 1 unit. I could change that if I wanted to, if I needed to. If I was going between 1,000 and if I was going between 0 and 1,000, right, I might want to make it in hundreds instead, each tick mark being 100. So I could actually do it that way as well. And I say I don't need anything to the left of 0, so I'm just going to change X to 0. Y we'll leave alone, but I could change that if I wanted to, but I'm not. And now I just hit graph, and now that's changed my graph paper. So I just get the piece I'm interested in. And if again I want to go back and what I normally do no matter what, if I'm going to do a graph, I do a Zoom Standard or Zoom 6. And that sets me back up with my standard graphing window that I can operate on. I usually start out there and then adjust accordingly. Unless I'm doing a data problem, which you guys haven't done. But, and then I have to adjust given what my data is.